Hi everyone, and today in the workshop, well, the video game garage this is, we've got a Star Wars Trilogy pinball machine by Sega that a customer sent in to be repaired. Now I've actually had this for a while, but I've had too many machines in here to be able to get to it and set it up, so finally I've got some room. So, plugged in the mains, let's give it a fire up. Okay, that's not, that's more broken than I was expecting. Let's just try again. So we've got some display activity then. Okay, it's not booting. I thought it was actually working with faults. Alright, let's open the box up and see what's going on. Poke around in the back here. So first thing I notice, unusual layout for these. Normally the display driver board, which is that one there on the left, is mounted on the back of the DMD, but in this case it's not. It's probably not that unusual, but most of the ones I've seen always have it mounted on the back. Anyway, that fluorescent tube is on its last leg. It's making a funny noise, and look at that blue glowing. That's kind of cool. That sort of blue sparking away in the end. Yeah, needs a new tube. No batteries. No immediate signs of corrosion. Excellent. So looks like someone's pulled the batteries on this before it's eaten the board, which is a good start. We've got power to the board, but it's locked up. We have some voltage rails missing on the driver board, so we've got some blown fuses, I guess. Not sure why the CPU's not booting. Let's see if we can look into that further. Right, board looks in decent condition, but what I've done is I've reseated all the ICs. This ROM socket seemed a little weak, so I might end up replacing that. Fingers crossed, let's see if it makes any difference. Let's give it a boot up. Oh, that's boot. Ah, that's loud. Get that turned down. Okay, we're booted. Fantastic. Okay, so I think that ROM socket is bad. That's what caused that problem. So, at some point, let's pull it back off again. At some point, we're going to be taking these boards out. We can see there's been some bodgery afoot in here. Someone's been replacing transistors from the top side of the board without taking the board out. Oh dear. Don't like the look of some of these. Yeah, that's lazy, isn't it? Just soldering it from the top, sticking them in, not even cutting the legs. Look at that, nice long legs. We've got a fuse out, we've got a connector taken off. I think we've got some shorted MOSFETs probably on this. But we'll have a proper look on the bench at some point. What I might do is get it into test mode and just check out what works and what doesn't. The battery holder does actually have a little bit of corrosion on it. Oh, sorry, it's hard to get this torch in. You can see a bit of brown on those springs. Nothing terrible, but we'll get that removed and make sure that the area around the battery holder is neutralised, just make sure no corrosion appears. I'll also ask the owner if he wants an NVRAM fitted. It's dead easy on these games, just take the RAM out, stick the NVRAM in. Right, so next step, let's go through test mode and see what works. I'm not going to test this any further. I'm going to pull this I/O board out and stick it on the bench. It definitely needs some work. It's very evident that this area here needs repairing before anything else, really. We are on the bench with the driver board, and we can see some complete monkey with a soldering iron's been here. Oh dear. This is not good at all. Oh, so many of them as well. So, let's see, where are we? These are all high-powered MOSFETs. Looking at the positions. What the hell have they done? So yeah, they trashed half the tracks and through holes. Let's do some testing, see if we can see if any of them are shorted currently. Quick view of the top so you can see the bodgery. These transistors, well, MOSFETs over this end, are stood up because they've not been replaced properly. Looks like, again, they've been done from the top. Looks like someone's ripped them out and then tried soldering from the top. That's why it has no solder on the other side on a lot of them, and they just look awful. The things we can do as a quick test is basically clip onto the ground and check for dead shorts on all these output pins. So 1, 2, 3, 4, 5, 6, 7, 8, 10. 10 is a ground, I believe, so we'll ignore that one. 1, again, a ground, I believe. 2, 3, 4, 6, 7, 8, 9, 10. 1, 3, 4, 5, 6, 7, 8, 9. 1, 2, 4, 5, 6, 7, 8, 9. Alright, no obvious dead shorts on there. So one thing we can do is we can actually power up the board, and we can use a load tester to basically check for current leakage by basically trying to put current through the MOSFETs and seeing if any of them are leaking when the board is powered up. You know, because when the board's powered up, you've got the logic that controls all the transistors and MOSFETs also powered up, and again, if something's leaking, we can then see the current on the outputs. So far, there's no obvious dead shorts, just a hell of a lot of mess. I'm going to take all this off and do it again properly. It looks absolutely awful. Let's do that now. I'm talking rubbish. Those are not grounds. Let me have a look. Yeah, so there's a big track goes up here to here. That's from bridge 2. That's the 20 volt supply, isn't it? Which it will be actually. These are flash lamps. That's going to be the 20 volt supply. So, where was it again? There. The 20 volt supply is shorted to ground. So that explains some problems. That's probably going to be that bridge. But let's check out the situation. It's finally happened. I've just been through and tested all the fuses and checked that they're actually the right fuses. And I think I've been repairing pinball machines for 13 years, maybe 14. I don't think I've ever had a driver board before on my bench where all the fuses are the correct value. They're not, as you probably see in previous videos, they're normally absolutely ridiculous. You know, like a 20 amp fuse where there should be a 1 amp and things like that. But this one has the right fuses, apart from a missing one. So let's repopulate that one. I thought I would take the capacitor off first, as it's easier than the bridge rectifier, as this has got the square pins and a right pain to desolder. Anyway, when I removed it, I noticed, oh look, sticky stuff. It's leaked some electrolyte. Let's get the capacitor. Oh, it's a 100% dead short. So let's just recheck the board. So, with the capacitor out, we no longer have the short. So we've got a little bit of corrosion to clean up. Unfortunately, that pad there, that looks a bit crappy. So what I might do is sand that away a bit, and then probably add a wire going back to that track there, just to reinforce that, as I think that's been damaged by the corrosion. To declare bonus nachos, as I've got a capacitor in stock of the right size. It's 15,000 microfarad, 35 volts. Now the original is 25 volts, 15,000 microfarads. This is a little underrated considering this is a 25 volt line. Not very much safety margin on that, so the 35 volt one will be better and last longer. Fitted, and as I said, I didn't trust that track on the top because of the damaged through hole. So I've added this bodge wire. I hate adding bodge wires, but this will make it more reliable. Also, when you're doing these bodge wires, leave a little bit of slack, don't go straight. The reason is, if I need to probe any of these pins, you can just move it out of the way a bit, otherwise it can hinder you if you go too tight with them. Okay, so what I'm going to do is apply some power and check that we don't have a short anymore, and the 20 volt LED should come on. Applying some power through F7, 20 volt light is on. If you remember, it wasn't on when it was in the cab. And we're drawing 12 milliamps, so that would probably just be the LED, and they're keeping the capacitor charged. It's probably slight loss through the bridge rectifier. Right, now that that's working, we can do a leakage test on the flash lamp circuits using the load tester. This section here is so dodgy, I've basically removed all of the MOSFETs so I can properly diagnose and patch up and repair as required. I don't know why, but every single one of the MOSFETs on the power section has been replaced at some point. That's really unusual. These are generally fairly reliable. You get the odd one or two MOSFETs on these Sega boards going. Also, use some horrible corrosive solder. So many of the through holes have been ripped out. I mean, I'll say, as you saw before, they were soldered in from the top, so it looks like someone's literally physically pulled out the old MOSFETs, pulling out the through holes and some traces with them, and then tried to solder them back on from the top. So, oh, this is a right mess. So there's no free holes at all in a lot of these. There's some particularly bad ones. So yeah, every single one of them has been bodged at some point. Obviously, I think this one here is burnt up. You can see all the charring, and you can see the charring here. Probably, and that one maybe as well. So it's probably had a couple burnt up. I don't know why they've actually ruined all of them. Additionally, some of the capacitors have been removed for unknown reasons, so I need to repopulate those. Don't know why. Yeah, let's get it cleaned up, assess the damage, and then what I'm going to do, I might reuse some of these if they look particularly new. They're all different mixes of brands and different ages. I might reuse some to save the customer some money if they look good enough. If not, I might put just brand new MOSFETs in. Right, let's clean it up.